Hello. Good morning. Wow, fast. All right. Good morning. Good morning, Daniel. Good morning, Jalali. Hello and good morning, Ashley. Morning, Jean-Pierre. Good morning, Nikaya. Good morning, Alyssa. Good morning, Yasmin. Wow, you guys are, wow. Good morning, Michelle. Good morning, Catherine. Okay. Uh, good morning, Professor. Good morning, Darina. Good morning, Professor Darina. Keep doing well in this class, and then that's what will be right. Okay, I don't know why I'm always so pleasantly surprised that you guys act like such a class. I mean, maybe it's because I don't act like a teacher. But good morning, good morning. Who am I? Oh, good morning, Molly. And sorry, no, she's coming. Good morning. Well, anyway, okay. Good morning, good morning, good morning. Yes. Okay. Okay. Whoa, whoa. We're gonna get started in a second, right? Okay, um, I believe you all got the exam itself posted on Friday. Just okay, wait, I'm gonna change the view here. Good morning, good morning. Right. It's like almost spring, and when we get through this exam, you'll feel even more like it's spring. And there's someone there that I have to let in. Sorry. Um, okay. Yes, and good morning, Molly, and happy Monday. That's an optimistic. I like that attitude. Yes, happy Monday to you. Um, happy my younger brother's birthday. Not that he would ever listen to this, but I'm just going to say this right now. On March 14th, which is 314, so it's often known as Pi Day, which is also Albert Einstein's birthday by coincidence. On March 14th, I had you guys your class. And then right in the middle of the class, it suddenly occurred to me that there's a very good friend of mine, a very good close friend, who's also the son of a very close friend of mine, who's also my original physics mentor. That person's birthday was also March 14th. And that person who I'm talking about, whose name is Eli, who was also born in Albert Einstein Medical Center. Not also, I mean, he's the only one that was, he's not the only one. I think other people have born there. But anyway, you almost always do try to remember his birthday, partly because I want to, and partly because it's not the hardest birthday to remember. And then I totally forgot about it this year, but then realized that in the middle of one of these classes, I totally realized that I had forgotten his birthday, and I didn't mention his name or anything, but I suddenly stopped and realized that. And then it turned out that he saw that fact later on, and let me off the hook for having forgotten his birthday. So I hear I'm officially, in case he sees this, happy belated birthday, not only to Einstein, but to Eli as Dorian. All right, but anyway, okay, now, okay, let's get straight, but but good morning, Molly, and good morning, Antonio. And good question from somebody in the private chat I totally want to address, and it's about the exam. So let's get straight to the exam. I want to say many. Okay, okay. I want to say many things about the exam, or maybe not many, but I want to make sure we're still on page with the exam. I am willing to answer questions about the exam, even though we're in the middle of it. So I apologize if this is out of sequence. Let me just start by letting somebody in. Pardon me. Okay. One question in the private chat is, it says this: I don't remember if I mentioned this before, but does the exam have to be handwritten or can it be typed out? That is a very legitimate question, even if I have said it before, because these kinds of things I do care about on an exam. And it's also reasonable to worry, to never quite know what I'm going to care about and what I'm not. So let me say on that question, does the exam have to be handwritten or can it be typed out? It can totally be either one. It can, but I understand why there's confusion about that. So let me see as clearly as possible. Let me back up. No matter what, I have to receive the exam electronically through Google Classroom, in the assignment portal. And if there's any issues with the portal that anybody already knows or anticipates, like, please let me know. But it is true that I have to, I mean, I guess this is obvious because we're in Zoom anyway, but I have to receive the document electronically through Google Classroom. But that electronic document could be a scan of things that you wrote out in hand. And that is usually the way I talk about it, because I think most people do it that way, blah, blah. But no, you can absolutely type out the exam for sure. Whether it's because it makes you more comfortable to do that, you, whoever you are, or because you're like worried about your own handwriting or think that I would like it better if your handwriting were clear if it was typed, or that I'd be more impressed like if it was. And yes, no, typed is great. Like I do want the thing to be very well presented. It's totally, and especially here we are on Monday. So yeah, presentation definitely matters. Presentation can be achieved by handwriting or typewritten. Either way, you really should do whichever one you think is going to make it look better in the end. I'm a big fan of multicolors. I'm a huge requirer of diagrams. Like the more variegated your exam is, the more it intersperses equations with diagrams, with English or whatever you're well, yeah, or any language that I can read. Like the better. So for some of you, that's much easier to put things like that together on a computer and like incorporate Google in Draw or whatever. If you're like a computer person and you can make something look good on the computer, interspersing your typewritten English or even then handwriting in the equations or whatever, then please do. Yeah. But if you're going to make it look better by doing it by hand, do that. Either one is totally, totally fine. But yeah, the tacit thing here is it should look good. Like it should be like a project, if you know what I mean. Okay, so I'm going to say more things about that. So very good question, just to repeat again, and maybe, and also with all these kind of questions, whether you give them to me privately or publicly, like it actually, I'll say this in general, like if I spend a while on a question, it would be great if whoever asked, if I still haven't answered it or if it's still unclear, please let me know in the private chat, or even just writing like okay in the private chat, so I know that even as a signal that I should move on is fine too. Okay, but so yes, typewritten or handwritten is totally fine. That's number one. Number two, let me just remind everybody, like you should know at this point that the exam was posted Friday around 6:30 or something. Like it should be in your possession. You should, that maybe you haven't started working on it. Maybe, it would be advisable if you had, but either way, if anybody, wait. Oh yeah. Okay. Wait. So okay, now I'm getting some bunch of questions in the private chat here. Okay, I'm gonna get to the private chat and let me just summarize. But good. So first of all, I am assuming I'm gathering that everybody does have the exam in their possession, like they got it. And anybody who didn't get or has a problem should let me know in the private chat. That's number one. Number two, I want to make absolutely clear that everybody knows it is due 10:49, 10:50 in 2 days from now. Like I know I keep saying it, but I have to keep saying it because I know I'm loose about other things and I'm not loose about this. And it can occasionally be an issue. You do have to turn this thing in at 10:50 and you have to show up to class at 10:50. If there's ever any day that and even if you have to go in 20 minutes indiscreetly or something, like you have to show your colleagues that you made it to class on time and that I have your exam. Okay. That's, um, that's number one. Wait, what was the other? And I know there's two questions in the private chat. Wait, there's something else about that. Oh, number two, just before I forget, the exam itself was posted Friday, but then just to be clear, I hope it's clear, like someone did find an error, a typo in it. So I hope you all saw that I posted a correction and re-uploaded the whole document like a day later or something. So number one, if there's any doubt in your mind at all, if there's any doubt in your mind, just re-download the corrected version and throw away the old one. If you didn't see the correction at all, check now, make sure you can, it's basically, I'll say right now, in the window problem, in the flower pot, excuse me, in the rock going up past the window problem, which is part 3, problem 1 or something. What is supposed to be the case is that the window is, now I'm going to forget, but I think it's 2 meters from top to bottom. And what is supposed to be the case is that we see the rock take a half a second to go from the bottom of the window to the top. In other words, to be clear, the flower pot was taken out of the practice exam. Like there's no flower pot in this problem. There's only a rock. And to be clear as possible, the information about the rock is supposed to be exactly the same as in the practice exam. Like, it's not supposed to be a trick. I wasn't trying to change numbers. I just accidentally left out the time. So, the guess that any of you would make if you panic, or if you're not hearing me now or something, if you panic and you realize the time is missing, yes, you are correct to infer that the time should just be the same as it was in the practice exam. But I accidentally left it out. So that's what the correction is. That's the only correction found so far. The reason we're here together today is if there's any other corrections or ambiguities, I do want to address them today. Okay, so that's the only one that I have found so far. That's number 1, or number 17 of my points. Next, and again, it still remains the case. You're all allowed to talk to each other. You're allowed to go on the web. You're allowed to use the practice solutions. But all the more things that you're allowed to do in order to do this exam right is all the more reason that I absolutely do care about how you present it. Your first and foremost standard in presenting this exam, I mean, in putting it together and making it to me, if you ever have any doubts in your mind, like, well, should I make it look like this? I mean, he's saying typewritten or handwritten is both equally acceptable, but which one would he really prefer, and stuff like that. The first standard is make the darn thing as easy to read and easy to follow as possible. Like, in all times, have in your mind, can I make this thing easier to grade? Like, 'cause that's your first standard. Like, make it easy on me so I can do it fairly and quickly and get to everybody's. Okay, but so for some of you that would mean typing it, but others, I personally would, if I were doing this exam, I would certainly do at least my drafts handwritten, and then maybe I would type them over if I felt comfortable doing that. But a lot of us think physics better with a pencil in our hand. Then it's easier to think about these things that way. And so don't kill yourself. Don't go to contortions to type it just because you think that'll make it look better. It may end up looking a lot worse unless you're really good at using a computer to incorporate equations and diagrams. Which brings me to one of the private chat questions. I just saw a second. Hold on, let me get it back. One of the private chat questions is, oh yeah, okay, and thank you for acknowledging my answer to the other one, private chat person. But then the question is, can we also hand draw diagrams if needed and put them into the type doc as well? Absolutely. Your exam could absolutely be an interweaving of different types of things, like some typed, some not typed. Like, you can use a computer for equations if you know how, but you don't have to use the computer for drawing, right? Yes, in fact, that's great. And I keep using the word interweaving because that is what we want. Like, one piece of advice, this got people into trouble in the other class in Physics 204. Like, your exam cannot just be equations, right? It can't just be equations. You have to explain what the equations are doing and meaning and stuff like that. But of course, there are going to be a lot of equations in your exam. There certainly are. What you do not want, whether it's handwritten or typed, what you don't want is just like a dense block of equations. Just go equation, 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 equation. You don't want that. Like, every equation you put in, here's one concrete piece of advice, the industry standard. Any equations you're going to put in your exam, and again, there will be a lot, right? Or you've already put in your exam. Every time you put an equation, it should be, at least within the space that you're writing, it should be like centered and by itself, like offset, so to speak. It should be like equation, and then centered right below it, maybe with even a line skip, the next equation. And then the next, like if you're dividing both sides by 2 or something, like doing algebra, you go like equation, equation, and then, but there's always should be pauses with English sentences saying, and then we divided both sides by 2. Or like an arrow and something over here, like, and then we divided both sides by 2. But don't, for example, what happens to some people in their typing, don't like start typing an English paragraph like, so then we looked at the acceleration of the object, and then we did this equation, and then we did that equation, and then like, don't just have a dense block of text with just equations in the middle of the sentences as though they were English words. Like, interweaving means go alternate between words and English and diagrams. Don't like smash them all together. I think you all understand what I'm saying. Now, I hope, and if not, please do let me know. Again, and I'm not trying to stress anybody out, but given that we have a whole week and stuff like that, the ideal version of this is that you work out stuff. Like, it would be hard to do this exam without doing some kind of rough draft first, like where you know that you've got it all right and you've got all your right answers and you're confident, and then copying it nicely. Like, I really, if what you give me is the first time you've thought it through, if you're thinking of solving things and crossing them out, as though you were in a classroom with a blue book, like rushing to get it through under the time pressure. That would be a mistake, because the one thing I'm trying to give you here is not that time pressure. So really, whatever you're doing, I would say one thing is give yourself, and still there's time, there's still 2 more days. I would at least try to do the physics in your whatever your way is on a piece of paper or in a book, but then copy it nicely for me and put in the diagrams and stuff. I mean, there should be at least one rough draft and one final. I'm never going to look at the rough draft, but if what you give me is the first time you thought it through, you're probably not doing yourself a service. But okay, now there's another question in the private chat. Okay, this is me. All right, I'm going to read this question out loud. I'm going to try to address this. I'm going to also just say, and I know I know who wrote it. And I know the person's working very hard. Like, I know this is coming from a very responsible, engaged place, this question I'm about to read. So I'm going to try to address it, but I'm also going to advise everybody that if you have a question like the one I'm about to read, I'll read the question. So the question is, it says, I'm stuck on part B and C of the solution to the Wile E. Coyote problem in the exam, in the practice exam. Like, so there's the Wile E. Coyote problem, which I guess is part 3, problem 1. Well, I'll look it up in a second. But the Roadrunner Coyote problem, okay, which I will now turn to in a moment to try to address this. Someone's saying, I'm stuck on part B and C of the solution. I will now turn to part B and C and look at it myself so I can try to address this. But I guess I have to say to everybody, especially because we're in the middle of the exam, I need something more specific than that for me to address this fairly to everybody. Like, this is advice, this is a request. Like, I technically that's not a question, it's a statement, and it's saying that the person's stuck on B and C. Now, again, I'm totally sympathetic, I'm going to look, and maybe there is a problem in my solution or something, so I'm going to look right now. But it would be more productive for everybody if that could be converted into a question, not just like, can you help me with part B and C? Because that's a little bit, we're a little bit late for me to just start talking vaguely about B and C. Like, I don't know what we need help with here. And also, I don't want to spend the whole period on just B and C if nobody else needs help there. So I'm going to turn to this now. I'm going to turn to part B and C because someone's asking. I'm going to turn to part B and C of the solution, but I'm going to ask either that person or anybody else to narrow this further so I don't just start babbling endlessly for 20 minutes, or my two alternatives, if someone just says, I'm stuck on the solution, is either I'm going to babble for a long time and try to reteach it and kind of probably say more than anybody wants or needs, or I have to just say, well, I gave you a solution, there's nothing more I can say at this point. So if that person or everybody else can say like something more specific, like, okay, that's helpful. All right, let me look. Okay, that's helpful. All right, again, the more the question to me could be a little bit more like multiple choice or true false would be good. But all right, I'm going to pause a second. I'm going to look at the problem. So we're talking, and everybody should. I mean, by the way, those of you, and also, I want to take this question very seriously because nobody could ask this unless they were already sort of working on the exam. It's obviously a responsible question to ask. And I'm going to answer any questions anybody asks because that's what's going to guide, right? Anybody who actually has a specific question should take priority over anybody who's just like sitting around waiting for everybody else to do the exam for them. So I'm going to totally honor this. But again, if any of you, the rest of you, are struggling with yours, the way to get me to answer your question best and to get me to move on would be also to ask something as specific as possible, like, where did this negative sign come from? Or are you sure it shouldn't be a positive sign, or something to me, something that really narrows me. And by the way, that's just good practice for everybody on their exams. The more specific you can be, the better. But okay, I'm going to pause. People can bring in more questions in the chat, but I'm going to turn now and find my document. Pardon me for 1 second. Oh, sorry. Hold on. Pardon me. Oh, okay. Oh yeah, okay. Oh, okay. Oh, okay, okay, okay. Okay. And I have to admit too, now that I'm looking at what B and C are, this is not so hard for a question for me to answer. I can see why. I mean, this is a fair question, to put it mildly. So maybe I should. All right, let me share screen for a second. Oh, and by the, all right, sorry. I'm gonna switch to screen share for a second. Okay. And anybody again can chime in here and tell me if they don't see the screen. But what we're talking about here, what I have posted is the actual exam itself. We're talking about and I think the scrolling works. We're in part 4, problem 1, the Wile E. Coyote. Okay, and part B asks for the time interval t equals 0 to time equals 5. How should the Roadrunner's velocity and speed trend? And then C, it asks the exact same question, but it's asking for the time interval, the next time interval from 5 seconds to 10 seconds. So it asks you to, these are actually multiple choice questions. It's asking you to choose one of the following 4, and then it asks you to justify. And let me be as specific as possible, and hopefully this will help with some other things. Notice this whole problem is worth 20. The whole problem is worth 20 points. I mean, it has 5 parts. So each one is worth 4. I mean, if you can assume that if I don't specify otherwise, you can assume all parts are equal weight. So each one is worth 4. And in a case like this, where I'm asking for an answer and a justification, it's pretty fair to assume that like the answer is worth 2 and the justification is worth 2. I will also tell you in terms of how I grade. Oh, and I see there's something else in the chat. Sorry, I just want to make sure I don't forget. Oh, cool. Thank you. Okay, so you see the screen. Good. Okay. So let me also take this opportunity to tell you how I grade or whatever. Like it's 2 points for each, 2 points for the answer, 2 points for the justification. Again, if I don't ever specify about points, you can assume each thing is worth like equal. Each subdivision is worth equal. I will also tell everybody, say something's worth, if something's worth, I mean, 2 points is about as little as anything could be worth. But even if something's worth 2 or 6 or 7 or a lot of points, the first thing I want everybody to know is if you write anything relevant at all, like even like if you write anything that shows that you know what the question is, then they're already getting at least a point, if not usually more. Like you cannot get 0 points on a question if you can only get 0 points on a question if you literally leave it blank or write something down that shows no appreciation of what the question is. Like you can't write, you're a cool guy, Yaverbaum. Like, no, okay. So first of all, if you write anything here, since each thing is already worth 2 points, if you write anything for each of them, you're going to get 1 point anyway, even if it's wrong. I'm just to tell everybody. As far as putting your answer, I know the person is asking me about justification, but for part B and C, just to tell everybody, like first I'm giving you 4 choices and I'm asking you to pick one. But I want everybody to remember, and again, this may be the trickiest part of the exam. You need to make the question clear to me when I'm grading. Like I am not going to have the test next to me when I'm grading. I'm only going to have your test, like on purpose. I'm going to have your blue book. So at every moment, you have to make it clear to me what it is I'm looking for, like what the question is. However, and I know, and maybe this is super picky, but it's super important. However, you cannot just cut and paste my question in and say, here's the question. You can't cut and paste. You have to somehow show that you know what the question is in somehow your own words, even if it means only changing 2 words or something. But like, and ideally you're just jotting some key things down. You don't want to like copy word for word what I'm saying. You have to show me that you get what the question is your way. So okay, like everybody. So even here, you have to write something like assume, like write for B. Okay, I'm talking about B right now. This is an example of how to communicate to me. In B, you would say something like assume T less than 5 greater than 0. Like you can use those like less than symbols, right? Assume T between 0 and 5. And then you can certainly say something like velocity equals question mark, speed equals question mark. Like, right? You're just, assume I know physics, but jot down what the basics of this question are. So now I know what to look for. Now it's multiple choice. I gave you choices. You don't have to tell me all the choices. You don't have to write down the 4 choices again. I honestly don't, I mean, you can, but I honestly don't care. You're just going to write down the choice that you think is right. Okay, so and I'm still haven't answered the person's question here. But first of all, for part B or C, you would jot down something to make it clear what the question is. And I'm a reader. So in B, you say something like assume t between 0 and 5, what's happening to v, what's happening to speed. And then in C, you can say now assume t is from 5 to 10, same question again. Like, you know what I mean? Like you just give me enough that I can follow. But so you're going to write your answer down for each, but then I do ask for a justification. And the private chat person is asking, how do I, like, what kind of justification am I looking for? Fair enough. I mean, very fair. What does it mean to justify here? First of all, it's only like a couple of points, so it's fair to assume I'm only looking for like a sentence. Like I'm not looking for a whole paragraph or 85 diagrams. I'm looking for like basically one complete thought, either a sentence of English, well, probably in this case, a sentence of English, or maybe a very clear diagram with some labels that make it clear. But I'm looking for something fairly specific. I can't tell you the exact answer, but I can tell you the best way to know what kind of justification I'm looking for in B and C is it's clear that I'm asking, well, I hope it's clear that I'm asking the same question here twice, but of two different time intervals, right? I'm asking for the same thing, what's going on with speed, what's going on with velocity, but I'm asking like, in this case, what's happening? And now over here in this case, what's happening? It's a good test taking skill. You would be wise, especially if you looked at my solutions, but even if you didn't, you'd be wise to infer that the answer must be different for these two questions, probably. Otherwise, why am I asking them? Or if the answer is actually the same, then there's some reason that's sort of surprising or interesting, right? So when you're looking for the justification, how to justify, what you should really ask yourself is, what is the difference between these two intervals? Like, what is it that's happening that Yaverbaum is asking me to focus on? Or maybe even put another way, ask yourself, what's like the surprise here? Like, why is this interesting at all? Like maybe ask yourself, apparently something's changing from 0 to 5, at 5 seconds, apparently something here is changing, but maybe something else is not. And that's why I'm giving you, well, I guess I did tell you the answer anyway. Sorry, I keep forgetting that you even know the answer to this, but like the whole point here is I guess I'll say, like the velocity, I mean, yeah, the acceleration is I don't want to tell you the answer, but the acceleration is constant here. That means the change in velocity is constant. The velocity is always changing in the same way here. However, I think it's fair to infer, and I think if you looked at the solutions, you can see, even though the change in velocity is always the same, like the velocity is continuing to decrease this whole time, yet somehow the speed is not. The speed is first going down and then it's going up. What I'm looking for in a justification is, how can that be? How can it be that first the velocity is doing one thing and the speed is doing the other, yet in the next the velocity is doing one thing, the speed is doing the other? In other words, what's a real justification? A real justification here would be like a reminder of the definition of velocity versus the definition of the speed. Something like, or the definition of speed. Something like, velocity includes direction, whereas speed does not, even though the direction of the velocity is never changing. Something like that. I'm not going to tell you the answer, but I'm talking like one sentence and one or two sentences that focuses my attention on the role of direction in this and how it could be possible that something's velocity could be decreasing for a full 10 seconds, yet the speed would be going down and then the speed would be going back up. Let me put it another way. This at 5 seconds, the special thing that happens is the Roadrunner turns around, right? It continues to accelerate in the same way, but it does turn around because it hits velocity 0. Like I'm saying a lot here. Everything I'm saying is correct. It's not a trick, but you don't have to say all of this. But somehow you have to make it clear to me, well, since the Roadrunner hits a velocity of 0 at 5 seconds, it must turn around in direction. Therefore, its speed starts going up rather than down, something like that. But just like a sentence. I've kind of said too much and too little at the same time. I'm not going to tell you exactly what to say. But that's the basic idea, is that it's always losing velocity. I'll say it in one last different way. This Roadrunner has a constant acceleration that is pointing in the opposite direction of how the Roadrunner was originally moving. Like if the Roadrunner was originally moving positively, it has a negative acceleration forever for the full 10 seconds. This Roadrunner is always losing velocity, but velocity numbers include direction. They include negative signs when applicable. So this Roadrunner is going down. It's going like, when it starts at 25, it's going like 25, excuse me, it's going like positive 25, positive 20, positive 15, positive 10, positive 5, 0. Now its velocity has to keep doing the same thing. Like it hits a velocity of 0, but nothing happens to its acceleration. So it keeps losing velocity. So now it goes to -5, -10, -50, right? So its velocity numbers are always going down. They're always going down, but they cross 0. So the magnitudes of those velocities are not, they're going down, and then the magnitudes are going up because the velocities cross from positive through 0 to negatives. You can't write all of what I just said. I mean, I guess you could, but I'm not asking you to write all of what I'm just saying. But everything I just said is the concept that I'm trying to put in everybody's minds. This thing's velocity is always going down, but it crosses through from positive values to negatives. Therefore, the absolute values of its velocities go down and then start going up because the Roadrunner turns around. And why does the Roadrunner turn around? Because it's originally going slower and slower, but its acceleration never changes. And why is it originally going slower and slower? Because its original acceleration is pointing in the opposite, direction from its velocity. That is, it's originally moving east, yet accelerating west. I'll say one last thing about this. Hopefully it'll help with the other part. So it turns out this was a great question. And I'm going to just keep talking about it, I guess, until someone else gives me a question. But the other thing about all of what I'm just saying, if you followed any of it, you who you are, or any of you, if you followed any of what I'm saying, please also notice that this coyote problem, you know, when you first see it, you might be like, where'd coyotes come into this? Like, how are we suddenly talking about coyote? Like, what is this problem? I've never seen this before in physics. But realize this whole problem is just it's just a gravity problem turned on its side. Everything conceptually that happens in this problem is exactly what we're supposed to be learning or understanding about what would happen if you threw something up in a gravity field. If you threw something up, the numbers are different, but if you threw something up at 30 meters per second positive, right, it would lose 10 every second. So it would be like positive 30, positive 20, positive 10, 0, and then negative 10, negative 20, negative 30. That, like, anything you're understanding about throwing something up in gravity is exactly what's happening in this problem, only like turned on its side. We're just trying to show what it means to have a constant acceleration, particularly when that acceleration happens to be pointing opposite to an initial velocity. Whenever an initial velocity and an acceleration are pointing in opposite directions, like whenever you have a positive velocity and a negative acceleration, or negative velocity, positive acceleration, then what you're going to have is slow down to 0 and then come back. It has to be that way if you understand acceleration and velocity. All right, that's a lot on that, but I hope I sort of addressed that question. That's that. One other chat. Wait, sorry, chat. Yeah. Wait, this is a good follow-up question. So follow-up question in the private chat is, does the Roadrunner start at the west direction because of the 40 meters due west? Yes, the reason I believe, wait, let me make sure I understand this. Right, the Roadrunner starts to the west of the coyote, therefore, but we know he's running toward the coyote. Like, oh, well, it says, wait, sorry. So it says in the opening paragraph, at this Wile E. Coyote is waiting at the top of a cliff, blah, blah, blah. That's paragraph 1. Paragraph 2, at a certain instant, Wile E. Coyote sees the Roadrunner is 40 meters due west of the bottom of the cliff. So the Roadrunner's over here. So here's the cliff. So back. Here's the cliff. Here's the Roadrunner over here to the west of the cliff. It says that he's running at an instantaneous velocity pointing east. So he's running toward the cliff. We know he's running toward the cliff. Well, first of all, because it makes sense. Otherwise, there's no problem. But he's running toward the cliff because the cliff is to the east and he's running to the east. but then it says specifically that the Roadrunner begins accelerating west at a constant rate. That's a key. He's moving east, his instantaneous velocity points east, but he's accelerating west. I mean, it says it in the paragraph. That's where I got that from. There's no way, I don't know if this is what the person's asking, but we're told that he's running east, and I think it's reasonable to picture that because he's like running toward the cliff. There's no way I would ever know he was accelerating west or accelerating east or accelerating at all unless I was literally told. Like, I'm not saying that a coyote couldn't, excuse me, I'm not saying a Roadrunner couldn't run east and accelerate east. He totally could. He could be running toward the cliff and speeding up. That would be like dropping something. But it just happens to say that he's running that way, yet accelerating the opposite direction. That means it's like throwing something up, moving one way, but accelerating the other way. Like, just because I'm told that his acceleration rate is pointing west, I only know that because I'm told. But once I'm told that, then everything I'm saying about the logic follows. Let me just look in the chat again. Oh, thank you. God, sorry. Okay, someone's in the waiting room. Why doesn't it say that? Thank you. Wait, are they? Oh, yeah, they are. Okay, so sorry. Thank you. Oh, and thank you for saying that. Okay, cool. I'm glad that if that was helpful, and I hope it benefited other people. Again, any part of this problem that I'm talking about, I mean, if I were in the class right now, I mean, again, maybe I'd be uncomfortable because it's like a new test, but the best things to listen to, folks, if you're listening at all, don't, of course, you want to listen to the parts that you don't understand. If someone asks a question about something you're confused, of course, you're going to listen then. But let me really advise everybody, the best parts to really listen to are the parts that you think you already do understand, even the parts maybe you think you've already filled out for the exam, like the parts you think are easy. Then it's really great to be listening to me then, because if you're already confident of the physics, then you're in a position to really hear what I'm saying about exactly the nuances of presenting that physics, if you know what I mean. But hearing me make all these detailed remarks about exactly what to say, if you haven't even thought about it all, is not very helpful, right? So what I'm saying is, a big mistake that science people make all the time is they tune into the stuff that they think they don't know, and they tune out for the stuff they know. No, you should tune in for the stuff you know, because then you can really see, then you can really get the benefits of the fine tuning. Okay, so I hope this has helped. So put one last, whatever I'm saying about this problem B and C here, and I think it was a good question that someone asked. You can also hopefully extrapolate from that hints and tricks of presentation that you could apply to any other problem in the exam. I also want to point out, I am, at first I was a little bit curmudgeonly when the person put in the chat, like, I'm confused about how to do a justification. But I'm glad they asked, and I'm glad I answered, and I'll say also why. Please, everybody, remember, in part one of this exam, my solutions did try to drag out the justifications and the presentations to give you a role model for that, or to give you like an example. But it's absolutely true that from part two on, my solutions are not showing you how to do that. So it's like very fair to be asking. Now, if I can't answer, I can't. But again, anybody only tuning in sporadically and thinks they're just going to copy my solutions, and I'm going to let somebody in. Sorry. Anybody who's only tuning in sporadically and thinking that they're going to copy my solutions for any part of this exam, especially any part other than one, is making a big mistake. Right? So recognize that the person who just asked me about this, it was wise that they asked me about the coyote, because it's true. Even in my solutions, I didn't tell you anything about justifications. I just like scrawled out answers. So fair enough. Okay. I want to pause. What I'm going to do right now, I'm just going to catch my breath for a second. I'm going to ask you guys to catch your breath, like flip through. You're allowed to ask questions today. I mean, I'm happy to go on to new material, and I will if there's no questions. Like, I'm not going to I will. But if you want to stall me, or you want to not get overwhelmed by new material, and you want to maximize this time to really make sure you're okay with the exam, this is the time. So, and if I can't answer, I won't, probably. But so everybody take a moment and like look through your own exam, and please again understand, like, even if you think you've already rocked this thing, that there's time at least to copy it over and make it better. Please do. So I'm going to pause for a second. So let's all pause and think if there's more questions like this or whatnot. And it could be, and if you think there's an error in the exam, this is definitely a good time to politely bring that up. But okay, so we're going to pause for a minute or two here. Oh, also, sorry, I'll put back a share of some kind in a second, but I'm getting myself confused. Oh, right. Sorry. So this is in the private chat. This question says, so you, Yaverbaum, want us to summarize each question, not rewrite it, right? Yes. I'm saying yes because I'm so glad that at least that proves to me that at least one person is hearing me. That is what I'm saying. Totally. It's probably, again, it's probably the most picky thing about me in these contexts, and it is not predictable. Like, one problem with me is I'm picky about some things and not picky about others. And until it's very hard to predict like which ones I would be. So I'm trying to make it as clear as possible. I don't think it's obvious, but it is true. I want each question to be somehow summarized, but not cut and paste or rewritten. That is right. Like, again, to everybody, and it's weirdly, in some ways, it's the place where people lose the most points. What I want in every single question is I want to be able to grade it without looking at anything else, right? But I don't want it cut it in. So I want to know what the question is before I grade the answer. Or put another way, pretend this is an article for a journal, which is really, really what this is all about in the end, is practice for that. Pretend this is a publication or you're bringing to a conference. you're walking up to a reader, or you're handing your presentation to a reader or whatever, or your magazine to a reader who does know the science but doesn't know what's in your head, doesn't know what your context is, what you've been doing research on for 50 years, right? You've been working on this exam for a week. It's all in your head. You have to walk up to me and be like, and start me from scratch on it. So that's why I need the question there in the question, so to speak. But the reason you can't cut and paste my words, even though of course, then that would be the safest, the reason you can't do this, then I never really know if you actually understand the question or not. Or in fact, to be honest, what I've learned over time is that if you just cut and paste my question and start answering, it severely increases your chance of misunderstanding my question. Forcing you to put in your words really ends up helping you make sure that you answer the right thing. I mean, even if it doesn't feel that way at the time. Okay. And I remember the professor that used to hold me to this standard when I was a freshman in college, when I was younger than you guys, but and I hated it. And he did it to me over and over, and I never got it right the first 50 times. And I thought it was so picky, but it ended up being the most valuable thing I learned. Like, really, is you've got to summarize my question for me before you then begin to answer it. So that is exactly right. And it's not the easiest thing to do in the world, because it means you really have to get the question. But the other flip of all of this, but so if it feels like I'm saying it way too many times, good, because that means you get it. Again, I promise in the other class, tons of points were lost all over the place for either this or for things that then cascade from not doing this right. Like, the most important thing you can ever do in science is actually know what the question is before you begin to answer it. Because as many of you have noticed, by the way, now here's the more optimistic thing to say, or whatever. I think many of you are starting to notice, like, the physics is like a lot easier than you thought it might be in many ways. And once anybody gives you a nudge in the right direction, a lot of the physics and the equations just like naturally follow. And it's not that hard to do. But what a lot of people will say a lot to me, or will just say, is like, I can do physics. I get what he's talking about. I can do it. I get the equations, but I never know how to start the problem. Right? Right. That is the hardest thing in physics, is how to start the problem. And the secret key to how to start a problem is start with the problem. Like, for real. Like, the reason people don't know how to start writing is they often don't quite know what to look for when they're reading the problem. And if you actually knew what the actual problem was, you would know how to start. So this forces you to do that anyway. But I wouldn't talk about it so much, except that it's where people lose points. So yes, but that person said it perfectly. Good. Sorry. And by the way, sorry to whoever I let in super late. I know you were waiting for, I forgot who it was now, but whoever was waiting in the waiting room for a long time, I totally apologize. And you have a good friend in the classroom who told me. I think it was Melissa. It was either Melissa who was waiting or Melissa who told me, but sorry to both of you. Now, Catherine, I wrote the question sort of how you did this. Right. I think this is right. And I think there's a public question. So, right. So what Catherine said, I wrote the question sort of how I did the solutions for the practice, where I have the given information, but written in sentences. Yeah, I think that is what I'm saying. Two things about that. I think that's right. You're right. Number one, as long as when you say you did it sort of how I did the solutions in the practice exam, as long as you, Catherine, or you, everybody, mean how I did the solutions for the practice exam in the very first part. Again, I got intentionally lazy after that. So don't mimic me for the rest. Just use the rest. But yes, as long as you mean how I did in the first part, I agree. Also, just to be as clear as possible, where Catherine and look, by the way, do you see what's happening here is at least one person in the private chat and now Catherine in the public chat, in a way, two people are just writing in the chat. They're just kind of summarizing in their own words what they think I'm saying right now. Like, they're just like affirming, is this the instruction you're giving us? How cool is that? Like, that's exactly what they should be. Like, even those of you might think, oh my God, geez, like, he's saying the same thing over and over. And now a student is even saying it in their words. My God, can we move off this? But you see, the students who are writing in their words what I just said, who are basically doing that thing going, so what I hear you saying is, like, that is a brilliant thing to do. That is what should be happening in communication. Like, if anybody ever says something to you that's important, before you ever say anything of your own thoughts, the best thing to do is go, so wait, let me get this straight. And here's my words for what I think I hear you saying. That's totally what should be happening in emotional communication and in scientific communication. Like, so I do want to commend, like, I know one person's doing it privately, one person's doing it publicly, but two people in this room are basically just saying, so am I hearing you correctly that you're telling us this? Like that's the right thing to do. And yes, they are hearing me correctly. And that's what I'm telling you. That is my instruction, is that when you're about to sit down and solve one of my problems, you're basically should be starting by saying, so what I hear this problem to mean is, what I'm reading this problem to mean is, and I'm telling you, those of you who do that well, those of you who summarize my problems back to me in your words, even like, well, you're already off and running. And so, like, not only are you probably going to get the problem right, but you're putting me in such a good mood. Like you're making it so easy for, like, then you're putting me on the same team as you. You're like, we're together, right? We're on the page here, right? Here we go. And I'm like happy then, like, okay. And what you're really also telling me is, here comes me, not Chegg, if you get what I mean. Okay. It's like if you at all have done any work and you want to make sure that I see that and that you're not just lifting things from Chegg or something like Chegg, or for another example, like Chegg. Like if you're not, if you want to show me that, then absolutely just echoing my words back to me, but with your words, is the way to show that we are having a dialogue that is worth every dollar of your tuition and every minute of my like not playing Nintendo. Okay, so yeah, so great. So I'm going to pause again for any other question, but yes to Catherine, yes to private chat person, yes to all of you. I'm going to pause again and see if there's anything. I'm going to pause. Yeah. And again, I've got new material. I'm not trying to threaten, but I could go to new material. I would be happily going to new material now, but I'm also just happy to help you out with this exam as long as it's constructive help like this. So let's take another pause. That's no one needs that. Okay. So, uh, oh, here's another, again, please, this is for your time. I mean, I hope the people so a couple of people did just ask questions, and maybe I was a little bit obnoxious at first, but I hope everybody's understanding that, like, well, yeah, I guess if I were in your position, it's a little tricky to ask a question, say, because you might be afraid that it shows where you are in the exam and you don't want me to know that, or so. I mean, I guess I get all those things, but it would still probably be wiser to err on the side of asking a question than not. And at worst, I just want to answer it. Like, there's also, I don't know, for the record, say one of you has never looked at the exam yet. Like, well, first of all, if nothing else right now, please make sure that you have the exam in your possession. Because it is true, if someone emails me Tuesday night or something and says, like, I never got an exam, then it would be then you would want to be a little bit embarrassed at that point to be showing me that you just figured that out the night before. But right now, it would not be an embarrassing time to let me know if you're missing something or something, like you literally can't do this thing. But similarly, at the same time, if you've got the exam in front of you and in your heart you're just looking at it for the very first time right now, I'm telling you that any question you ask right now is not going to give that away. I mean, I am very arrogant. There's a lot of things I do know. I can tell when I read your exam, like, really whether you know what you're talking about or not, even if I'm nice about it. But no, if anybody, just for what it's worth, even if you're turning to it for the first time now and you have a question about part A of problem 1, if you ask a question about that, it's not going to go through my mind like, oh my God, they're just starting this now, they're in trouble. No, what's going to go through my mind is relief that I can do something to help somebody right now and not just, like, fill up space. So don't let that hold you back. If you think I'm judgmental, you're right, but I'm not judgmental about that. Um, uh, 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 so also a piece of advice that occurred to me and by the way, also, I got some questions this weekend by text from some people, and some of them were harder for me to answer than others. Some of them were better than others, but I did try to answer all of them. And one of the questions I got was the person that found the error in the exam with the missing information. I'll even go so far as to say that that person also found another thing or two that I think they thought were errors or confusing, but weren't. And so then I was able to straighten that person out. Like, it's better to communicate than not, is, I guess, what I'm saying. And also, especially if you think already, just listening to this, if you're starting to notice you're going to run into time trouble, the worst thing you can do is just hand in this exam late and not have a prior explanation. If you think there's going to be a time issue, at the very least, you might want to give me a heads up. And then if it turns out that you're fine, then you're fine. You won't have done any damage by giving me a heads up, but you will do damage if you don't give me a heads up and the exam does come in late. Oh, also on that, if the exam does come in late, yes, I will be, I won't be happy about that. But just also to be clear, if the exam comes in late, like let's say an hour late, I can't treat the exam the same way as everybody else's. It's just not fair to everybody else. But also to be clear, I still will absolutely read it, grade it, give you a grade. I will deduct points. And exactly how many points it is, I can't say yet. But I do want everybody to know it is still better late than never, for sure. If you're ending up running a half hour late, don't then give up on the whole thing or say, well, screw it, I'm going to fail this class anyway. No, I will still totally read your exam and I won't be obnoxious about it. I just will deduct some points for lateness and then we'll move on with our lives. Like, if you were going to get an A, perfect. I can't give you an A if blah, blah, blah. But I will still absolutely read it, grade it, and give you a grade, and it won't be a failing grade. So, let's have that in context. Also, something just occurred to me, then I'll look in the chat. This came up with one of the questions over the weekend. Oh, yes. Here's another place I'm picky. I think there's a difference between a triple equal sign and a double equal sign. Wherever in that exam you think a triple equal sign applies, and I'll tell you right now again, triple equal sign means equal by definition. Some of the equations that we use have triple equal signs in them. Some have double. I do want you to know the difference. And especially since the equations are written out at the front of the exam, blah, blah, I do expect, there's some freedom on some symbols, like wherever I say V and V naught, maybe some of you write VF and VI or something like that. Okay, or V2 and V1. But triple equal signs and double equal signs, especially if you've never seen them in a class before, all the more reason to learn them in this class and use them. Okay, that's a real thing. Triple equal sign versus double equal sign. Now, all other notation, whenever you stray from my notation and use a different, like I always say V minus V naught over T, you can write VF minus VI over T, or you can write V2 minus V1 over T. I'll accept other notations for sure because they're equally correct. But just also know, if you use other notations, you are signaling me that you're getting your information from somewhere outside the class, which is totally okay. In fact, encouraged. But of course, I'm just going to watch more carefully then to make sure it's not coming straight from Chegg in some corrupt way. So just be wise and thoughtful about that. But okay, chat. Yeah, okay. Fair enough. All right. I just got another question in the private chat that even says, I know I already asked this question over the weekend. They have a question that they actually asked over the weekend. And I did answer it, but then they're saying in the private chat that they think it might be wise for me to say to the whole class. And I got to say, I was literally thinking in my mind whether I should just bring this up now if no one else has a question. And I will. Okay. Fair point. Thank you, private chat person. Now, again, a lot of the things I'm saying right now are really addressing like basically two people in the room. I think it's great for them. I know who they are. Well, I mean, one of them's Catherine, but like, I think it's great for them and great for, but like, for the rest of you, don't be left in the dust. Like, this is your time too. This is your tuition too, but okay. And I really do think it's better for me to answer questions than for me to just lecture at people in the middle of an exam, but okay. So here's it. Okay. What the person's I'm not like, I can't read the question out verbatim. It won't make sense to people, but what the person in the private chat is reminding me, the person is reminding me that when I solved the boat and stream problem, the Galileo's principle of relativity problem. Well, here, I'll share the screen. Hold on a second, sorry. Yeah, okay. So the person is asking about, oh, and I'm sorry, also just a song, like, oh, yeah, no, okay. Yeah, the person is Windows, blah, blah, blah. Okay, this question here, which again is, it's worth, this whole question's worth 20 points. It's not broken down into parts. You have one goal in this question to get the speed of the river relative to the shore, the speed, or I believe actually. Yeah. All right, the question is, so I'm looking at the bottom of page 4. The question is relative to shore, i.e. compared to shore, i.e. in the frame of reference of the shore, i.e. if you assume that the shore is at rest, like if you're standing on the shore or you're a piece of dirt on the shore, or you're a boat on the shore, but sitting there on the shore, watching the river, what speed would you measure the river to flow? What speed would you see the river flowing? Like, that's the question of the question, okay? That's the whole question. The whole thing is worth 20 points. I didn't divide it into parts or anything. So in some ways, this is the hardest question of the whole exam in a way for you to organize your thoughts. Because I'm telling you the answer is 1.5 meters per second or miles or whatever, miles. It's 1.5 miles per hour. That's the answer. So if you just write down 1.5 miles an hour, no way are you getting 20 points, right? You're gonna have to explain this and break it down into parts and stuff like that. But I did give like a scratched out solution, and there's something in my solution that may be confusing to people. So I'm going to explain it. What time is it? Okay, first of all, I'm asking here, what is the speed of the water relative to the shore? Okay, first of all, remember, all speeds, all velocities are all relative. Like, this problem is called Galileo's principle of relativity because it's like forcing you to very directly and explicitly confront the principle. In order to do any of the rest of the exam, you have to understand the principle. It's all over the exam, particularly those helicopter problems and the Yaverbaum problem. Like, this exam makes no sense unless you understand relativity, or you can't get right answers unless you understand relativity. But here, it's like forcing you to really be direct about it. So the first thing I'm saying is, if you're confused when I say relative to shore, or if you think that's just like an obvious throwaway, then you're not understanding something. All speeds must be, and all velocities must be a comparison between two objects. In this case, I'm asking the comparison between the water and the shore. The underlying implication is that if you get the speed of the water relative to the boat, that is also a valid number, just as valid as 1.5, but it's a different number. like that. And that's a different question. Like the boat would see the water doing one thing, the water would see the boat doing one thing, the water would see the shore doing one thing, the shore would see the water doing one thing, et cetera, et cetera. Okay. That's number one. Now, the other, so speeds and velocity are relative. Speeds and velocities are relative. They're relational. What's the difference between speed and velocity? Well, remember, speed is the magnitude of velocity. Velocity is speed and direction. Speed is just the speed part of that idea. So in the end of the day, what I'm asking for here is a number. At the end of the day, I'm not asking about direction or anything like that. Your final answer will be something like the water flows past the river at a speed of 1.5 miles per hour. I mean, okay. But in order to get that, we have to do a bunch of calculations. And most of the calculations we're going to do are like with velocities. Like we have to account for direction while we're thinking. We have to account for direction while we're analyzing, otherwise something could go wrong. So at the end of the day, let me put it this way. If I had asked, what is the velocity? Excuse me. If I had asked relative to shore, what is the velocity at which this water flows? Then you would have to give me a number and a direction. If I asked velocity, all of you would have to say something like the water flows at 1.5 miles per hour north past the shore, or south past the shore, or upstream past the shore, or downstream or something. You'd have to you'd have to have like a little labeling system where positive means north or something like that. Okay. Now I didn't ask that. I just asked for speed. So whatever answer you're getting when you do your calculations, if it has a plus or a minus in it, at the end, you're going to get rid of that plus or minus, and you're just going to give me the number because I'm just asking for speed. Okay. But so why do pluses and minuses come into this at all? For this reason, because the way I solve the problem, the trick, like what you want at the end is how fast this thing is going according to the shore. But if you try to solve the problem from the perspective of the shore, like if you solve it correctly, you'll get the correct answer because that's what I'm asking. But it's really hard to solve the problem from the perspective of the shore. Because from the perspective of the shore, you see this boat going like that, like going up somewhat and then coming down a completely different length. And you see it going up at one speed and coming down at a completely different speed. I'm not saying it's not solvable, and I'm not, but it's really hard. The advantage of relativity, the whole thing of physics, is that physics works out the same in all different perspectives. All different perspectives are all equally correct, but some are easier to work with than others. So again, going back to what people often say about physics is, oh, I can do it once he gives me a little nudge, or I can follow what he's talking about, but I never know like how to start it on my own or whatever. Right. The hard part of physics is starting on your own, because what we're supposed to do, because people just want to like do math, especially when they find out the math isn't even that hard. But the thing about physics is you have to make choices that enable you to set up the math. And the first choice you have to make in a physics problem might be just as simple as, what am I going to call positive and what am I going to call negative? But even that simple choice is a representation of this larger idea that you are picking your perspective based on what's the most convenient perspective to pick, and based on this belief that all perspectives will work out, but some are more convenient than others. So for example, in this problem, you're going to start by saying, let's observe the problem, or let's solve the problem from the perspective of the water, or as the water sees it, or as the bottle sees it, because the bottle is in the water. The bottle is one object, the water is a different object, but they are both the same frame of reference because they're both traveling together at the same speed, same direction. So we're going to solve this problem from the perspective of the water. From the perspective of the water, we see a boat go up a certain distance at a certain speed and come back down the same distance at the same speed. It's a much easier problem to solve. We're going to solve the problem from the perspective of the water. And what we're ultimately going to get from the perspective of the water is the speed of the shore. What I'm saying is, if you're following me, if you're doing the calculations or the logic or whatever, if you're looking, if you're pretending it's like a video game and you're the bottom in the water watching what's happening, you're going to see this boat going up away from you for a while. You're also going to see a bridge going up away from you for a while at a slower rate. then eventually you're going to see a boat start coming back down to you while the bridge keeps going up. The bridge is attached to the shore. You're going to see a shore going up, up, up for a while. And if you do your calculations correctly, you're going to find that the shore is going up at a speed of 1.5 miles an hour away from the water. You're going to find that the shore is going up at 1.5 miles per hour relative to the bottle. Relative to the bottle or relative to the water, same thing. Let me say that one last time, and I know that we have 4 minutes left. If you're solving things and doing things correctly in this frame of reference of the water, what you'll find out is the velocity of the shore relative to the water. You're going to conclude that, say, the bridge is moving up at 1.5 miles per hour relative to the water. And you're going to get that 1.5. But the question is asking, what is the water doing relative to the shore? So you just have to be smart enough and clear enough to say, oh, aha, okay, I'm not at the answer yet, but I'm just about there. Because, okay, I know for me. Well, I'll say it in English and I'm going to write it down. It'll be the last thing I write down today, I think, or the last thing I say. Because what we know about relativity is VAB equals negative VBA. What we know about relativity is if you believe that the sun is going west past the earth at 65,000 miles an hour, that means that the earth is equally legitimately going past the sun at 65,000 miles an hour west, like in the opposite direction. If I'm going past you at 50 miles an hour to the north, then you're going past me at 50 miles an hour to the south. Like both are equally true and one always follows from the other. Velocities are mirror images like that. So, and then, so I know we have 2 minutes. I just want to write this as clearly as I can. So I'm going to switch to sharing. Okay, what I'm saying is, this is in your notes and it's on, like, this is not the first time I'm writing this, but like the mathematical way to write down what relativity means is just this, is the 3 cases. In the case of one object, the velocity of something relative to itself is always 0. Nothing has velocity by itself. I am always moving at no speed relative to myself. My glasses are always right in front of my face, right? That's case 1. Case 2, if you have 2 objects, the velocity of me relative to you is always the opposite of the velocity of you relative to me. If I'm going east at 30 miles an hour to you, then you're going west 30 miles an hour relative to me. That's what the case 2 thing says here. And then case 3 says, velocity of me relative to New York City equals velocity of me relative to a subway plus velocity of subway relative to New York City, right? That's the 3 object case. What I'm talking about here, I know it was 1 minute, what I'm talking about here to answer the person's question, and in this problem of the boat and stream, I'm saying we do all our calculations to find out what the shore is doing relative to the river, to the water, but then we know that what the water is doing relative to the shore must be the exact opposite. So I wrote that down. Like, I know that if I got the answer of the shore relative to the water, then all I have to do is negate that to get the water relative to the shore. So if the shore is going 1.5 miles per hour up relative to the water, then the water must be going 1.5 miles an hour down relative to the shore. And that would be my final answer, except then the question actually doesn't even care whether it's down or up. It's just asking speed. So I cross the word down out of my mind, or I cross the negative sign out of my mind and leave it off. In other words, I'm using this thing right here to get the answer. I'm using that negative sign says one thing is equal to the other, but flip the direction. It wouldn't be valid if that negative sign weren't there. It wouldn't make any sense. But So I'm using it, but then in my final answer, I'm tossing out the negative sign because no one's asking for it. That's all I have to say about that. I hope any of this was helpful. Really, really. I look forward to taking your exams on Wednesday, and then we'll move on in our lives. And Wednesday will not be a stressful class. Once you turn it in, it's the hardest thing you do. Then you show up and we'll do something a little bit like more relaxing, but it will be physical. Okay. Everybody good? I'm going to switch the view. And I will post this recording. I will tonight if it helps at all. The other class coming now. So are we good? Goodbye. Can I get a goodbye? Or are we good? Goodbye. Goodbye.
Thank you, Professor. Bye.
Thank you very much. Oh, thank you, David. I didn't even see you. Thank you, Zilali. Thank you, Catherine. Thank you, Antonio. Bye, Nikaya. Bye, Alyssa. Thank you. Thank you, Noelia. Oh, I didn't see you. Thank you. I didn't see you before too. Thank you for Jennifer. I didn't say hello before. Thank you, Dorina. Thank you, Luna. Goodbye. Goodbye. Thank you, Yasmin. Thank you, Catherine. If I didn't say, sorry. Thank you for the great question. Okay. Thank you, guys. Good. Thank you. You're welcome. I mean, yes. Awesome. Everybody loves everybody. Okay. Okay. Peace. You guys are good, Dorina, Catherine, Jennifer. You guys are good. Okay. Bye. Thank you very much. Bye. Awesome. Thank you, Okay. Awesome. Awesome. Thank you. Goodbye. 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 Jennifer, you good? Do you hear me? You see me? Okay. Bye.